Hi scholars, today we're going to talk about percent change. And so one way of thinking about percent change is there are many contexts where you have an initial amount of something. This could be your salary, this could be a population, this could be the price of a good or service, right? And something changes, that initial amount either increases, right? It could increase or it could decrease, and then you have a new amount. Now if it increases, this new amount is going to be larger, of course, than the initial amount. It'll actually grow, and if it decreases, it'll be maybe smaller, right? But the idea behind percent change is it's not enough to just say how many more, how much more did I add to get to this bigger amount, or how much more did I subtract to get to this smaller amount. I want to interpret how much we're adding and how much we're subtracting within the context of what I started with, of the initial amount. And this is the big idea behind percent change. So let's take a look at a couple of ways in which we can calculate it, and then we'll do one quick example. So a percent change formula, we talked about how we have an initial amount, what we start with, and a new amount. There's two ways we can calculate percent change. One way is to find the difference between the new and the initial amount, right? And this is that number, when you find the difference between the two, is going to tell you, is the thing increasing or decreasing, and by how much? But again, we're going to compare it to the initial amount that we had, okay? And this number will end up being a decimal. We're going to convert it into a percentage. So this is one way of calculating percent change. Another way is to just calculate the ratio of the new amount compared to the initial amount. And we're going to do an example of both of these ways in just 1 minute. And we can calculate that, and then you take away 1. And you think, wait a minute, these two formulas look really different. I don't understand. Well, let's just make sure that they are actually the same. Remember, I can start with this formula right here. And remember, when I divide by the initial amount, right? I'm dividing by the initial amount. I can actually split this fraction up, right? So if I had written, for example, if I had written 5 minus 3 over 2, I could have split that up as 5 over 2 minus 3 over 2, right? So we know we can do that. So we're just going to do the same thing, only we're going to do it with this formula. So instead of I'm going to split this up as a new over initial minus initial over initial. And this thing is equal to 1, right? If you have any number over itself, it's just the same as 1. So this formula turns into, this formula right here, right? So we can, let's take a look at how this looks, what this looks like in a real example. So for example, a week ago, Theo could recognize 15 words like mom and dad and dog. And of course, he's talking about Gnarly the dog. And now he can recognize 24 words. That's not too bad for a week. Question is, by what percent has the number of words that Theo can recognize increased? Okay, so let's calculate this in two different ways. So our first way, we said, well, first off, what counts as the new number of words and what counts as the initial number of words? So here, right, since he can now recognize 24 words, this is our new amount, and he used to be able to recognize 15, so this is going to be our initial, or our starting place, right? That's his starting place. So if we wanted to use this formula, you guys have just copied it in your notes, right? We could use that first formula and say the new minus the initial, so that'll be 24 minus 15 over the initial, okay? And we can do that calculation. 24 minus 15 is in fact 9 over 15. And when you plug that in your calculator, you're going to find out that the answer is 0. Here, I'll do it this way. The answer is 0.6, okay? And the question is 0.6, what does that mean? Oh, I know how to convert decimals to percents. That's what we learned last week. So 0.6 is equal to a 60% increase, okay? So while he learned 9 new words, right? These are the new words that he learned. Well, so these are, we can use a different color, okay? So we can call this, these are the new words, right? That relates to, those 9 new words actually relates to a 60% increase because he used to be able to do 15, now he can do 24, right? We're comparing this 9 in relation to the initial amount, what he used to be able to do, okay? So let's use that other formula. And the other formula that we said was equivalent. So these are the same formula, right? So I'm going to make this double arrow. It means I can either use this one or that one. It's the same thing. So the other formula said, let's just do the ratio of the new over the initial. And let's see what happens when we do that. So if we want to do, here, here's a different color. If we want to do 24, so that's the new, over 15, the initial, we can plug that into our calculator, and what do we get? Well, we get 1.6. Interesting, right? There's something that's similar with these two numbers, right? It's just off by 1, right? And so if we want to continue with our formula, I can say subtract 1, and you do get the 0.6, and it's the same answer for sure, right? Now this 1.6, we might want to ask ourselves, what does that really mean, right, within the context of this problem? And the 1.6 means that it's basically like this 24 is 160% of the 15, right? And if he had, we can imagine, right? We can imagine, let's say he did 15 words last week and now he does 15 words again, right? We would have had 15 over 15. We would have just had a 1, right? He knows 100% of the words that he knew. But here, we're able to say he knows 160% of the words that he knew, which is an increase of our 60%, okay? So these are two ways in which we can calculate percent change.